All right, I apologize. I have to go through this really quickly because Wolfram, or they only give you 5 minutes to do this. So I apologize. I can't do any detailed explanations. There's only 5 minutes. So let me go through this straightforward, and you can read this stuff too and pause and read it. When you're doing a differential equation, the first thing you do is you identify what kind of differential equation it is. Once you identify what it is, then you'll know the solution method. This course can be the easiest course on the planet. It's just tedious. Okay, it's all just integration and differentiation and applying formulas. So when you're in a differential equations course, number one, you identify the differential equation. Number two, you identify the formula. Number three, you apply the formula. Number four, it's super tedious. You make a whole lot of mistakes. You get the answer wrong. You still pass with an A. Okay, been through this course so many times. Don't try to understand any of this. Okay, just you identify the differential equation, the ODE in this case, ordinary differential equation. Then you apply the formula, and then you make a whole bunch of mistakes, and you pass, no problem. Okay. As long as you know which formula to use and you know how to identify the differential equation, the arithmetic is just busy work after that. Okay, the rest of it, the arithmetic's just worth nothing really. It's just about identifying. So first of all, this is a first order because it's the first derivatives in there. X prime, first order. Now it's separable because if you see here, I'm going to go through this quick. You can pause and read all this stuff. It's separable because I have the product of two different variable functions equal to a derivative, which means I can separate it out into two basic integrals. And you'll see here, so if I use basic algebra, the sum in the exponent is the product of the elements, then I can separate it out. I add my integral sign. Now look at that. It's just basic. Now it's just a basic calculus 2 question. So now you integrate the left side using integration by parts, integrate the right side just using regular e to the, whatever integration, just basic integration. You get your answer here. Now you solve for c, the constant. It's an initial value problem. They give you an initial value. So 0 would be my t value, and 1 would be my x value. I solve for c. I get this. This should be a 1, I believe, or maybe not. I don't know. I plugged it into Wolfram. I'll show you if I got time here. So now I find c. So now I plug c back into this, and I get this equation right here. So now I have that equation. That's the implicit solution. Why is it implicit? Because we cannot solve for x explicitly. You have explicit, you have implicit. You have general solution, you have particular solution. This with the constant in it is this part here with the constant in it is the general solution. When I put the constant back in, now it's the particular solution. So I have the implicit particular solution of this first order separable variable, non-homogeneous, not homogeneous. If someone says homogeneous, ask them, are we in a dairy farm? Because homogeneous is a term for homogenizing, separating fat from milk. It's homogeneous. Okay, so just proper pronunciation in the professional world. How much time do we have? Okay, now once you find the solution, all you have to do is take t and plug t into here and approximate x. I'm going to leave that to you because I don't know what calculator your professor wants you to use. Do they want you to use Wolfram Alpha or something? You're not going to be able to do this by hand unless you use Euler's method or something, which would be still horrifyingly tedious. So maybe MATLAB or some type of computer program. I don't know. But you can go to Wolfram Alpha here. And let me check the time again. I got less than 50 seconds. Let me try to do this really quick. Oh my God. So I could take this right here. See if they'll copy and paste for me. I can copy and paste this and say evaluate this at t equals that. And okay, so evaluate this at, let's say 1. Shows the at somewhere t. So then does it give me an approximation? So you'll have to, you might have to play around with this. I don't have time to go through this on that. So peace.